Many recent developments in concrete materials and processes allow new and repaired pavements to be open to traffic at a very early age. Because new mixes produce rapid strength gains and high early strengths, concrete has become a more cost-effective repair material. As a result, materials and design engineers working together in pavement management can address the specific problems of the pavement and still minimize closure times and traffic disruption. This video presentation is the first of 5 that address the rehabilitation of highway concrete. It introduces several specific measures for rehabilitating both concrete pavements and concrete structures. The information contained in this and the other 4 videos stems from sharp research into the optimization of highway concrete technology. The series is accompanied by a user's guide and by guide specifications that result from the research findings. While there are several rehabilitation activities that can be performed on concrete pavements, we will focus on ones that require the use of cementitious materials for repair. Activities such as partial depth spall repairs, full depth repairs, and full slab replacements, and concrete overlays of existing pavements. Like pavements, concrete structures can be rehabilitated in a number of ways. So we'll also look at the placement of bridge deck overlays as a means of restoring rideability and reducing the concrete's permeability. The type of rehabilitation activity to be performed depends on the type of distresses exhibited by the pavement or structure. The first step in assessing the need for concrete rehabilitation is determining what distresses are present and which ones require rehabilitation. This is typically accomplished through a condition survey, in which a pavement or structure is visually inspected. The distresses are noted and documented, not only the type of each distress, but also its severity and extent. Distresses of higher severity or of greater extent indicate more severe deterioration that will require more extensive rehabilitation. So the type, severity, and extent of these distresses indicate the method of rehabilitation that should be considered. Let's turn our attention first to pavements. For example, severely deteriorated joints are best remedied by using full-depth repairs in which full-depth saw cuts are made on both sides of the distressed area. The distressed section is removed, and new concrete is placed and doweled into the existing pavement. If there's extensive distress throughout a slab, replacing the entire slab may be more cost-effective than making several separate full-depth repairs. Full-depth repairs may also be appropriate for deteriorated transverse cracks. Joint deterioration limited to the upper 1/3 of the slab is a candidate for partial depth repairs, in which the extent of the distress is located and marked. Partial depth cuts are made at the boundaries. The distressed concrete is broken up and removed. The repair area is thoroughly cleaned. Bonding grout is applied. And the repair material is placed. Concrete overlays may be appropriate under certain circumstances. They may be either bonded or unbonded. An unbonded overlay may be constructed if the existing concrete pavement is badly deteriorated. Specific measures are taken to prevent the overlay from bonding to the existing pavement, so that distresses in the existing pavement will not reflect through to the overlay. Normally, a layer of asphalt concrete is placed as a bond breaker or separation layer. And then the overlay is placed. A bonded concrete overlay is placed on a concrete pavement in relatively good condition. Its purpose is to increase the structural integrity of the existing pavement. Specific steps are taken to ensure that the overlay bonds to the existing pavement to form a monolithic structure. The existing pavement should first be thoroughly cleaned, or its surface prepared by an approved method, so that an adequate bond may be achieved. Most agencies then apply a bonding grout to the pavement surface just before placing the overlay to enhance the bonding between the two surfaces. As was stated earlier, many recent developments in materials and processes allow for concrete repairs and new pavements to be open to traffic at a very early age. For example, full depth repairs can be constructed to reach a flexural strength exceeding 300 psi in as little as 4 hours, permitting them to be open to traffic that soon. And overlays or reconstructed slab sections can be open to traffic within 6 to 24 hours when fast-track mixes and paving procedures are used. The methods of obtaining accelerated strengths include using a Type 3 cement, adding an accelerator to the mix, employing curing blankets, and using a water reducer. Advancements have also been made in the rehabilitation of concrete structures. Like pavements, structures can exhibit many different types of distresses. One of the more common problems with concrete structures is the deterioration of bridge decks, consisting typically of cracking and spalling. This deterioration is generally attributed to the corrosion of reinforcing steel due to the infiltration of chlorides into the deck structure. An overlay of the bridge deck will restore the riding surface while making it largely impermeable to the penetration of contaminants. In this procedure, the bridge deck is prepared by removing delaminated material, scarifying the surface, and then sandblasting the surface. After this surface preparation, a bonding grout is applied, and then the bridge deck overlay is placed. Because reducing the infiltration of chlorides into the deck structure is so important, special mixes are often used on bridge decks. One such special mix is latex modified concrete. When used with Type 3 cement, the overlay can be open to traffic within 24 hours. Another special mix used for bridge deck overlays is silica fume concrete. This material has low permeability and therefore greatly reduces chloride infiltration. Yet another special mix is low slump dense concrete. Thousands of this type of overlay have been constructed. In this video presentation, we have introduced several rehabilitation activities that can be used for concrete pavements and structures, including full depth repairs, partial depth repairs, concrete pavement overlays, and bridge deck overlays. The other videos in this series demonstrate in greater detail the construction of these concrete rehabilitation measures.